Now I guess we're gonna get to bash RC. This is gonna be some more advanced stuff we can talk about. Oh, actually, I forgot. Before bash RC, I promised I was gonna talk about alias and functions. So let's do that first. So alias is alias is an older way of doing things. Alias is how you it's a alias foo equals bar. So what this will do is whenever I say foo, it'll replace it with a bar, which is kind of simple. So like one of the things you can do is you can say alias g equals git. So g commit, stuff like that. So now you don't have to type git all the time. Or well, I use Kubernetes at work, which is this. So I do alias k equals that. So now I can do k git pod, stuff like that. I don't have that on my computer, but you can do things like this to make your life a lot easier by using aliases. We'll talk about why we put those into our bash RC in a bit, but these aliases really make things easier. Another really helpful thing you can do is, I hate normal ls. I really like this one because it gives it a nice, neat order. Just tells you all the things in a row. So what you can do is you can do alias ls equals ls minus al. So now whenever I do ls, it'll do that for me. It'll give me those arguments. And then you can do like period, and it'll get list here. You can do like slash, it'll list everything out there. Whoa, there's a lot of files. Things like that. So you can do you can do these aliases, and you can give arguments to the aliases. The limitation to aliases is that you can only add new arguments to the end. So like you couldn't say, I want to say like echo or alias, and I couldn't use this to say foobar. I could not use e to say foobar because it'll always be bar and then something. And that's the problem with aliases, is that they can only have things appended to the end of them. So they're really easy to make, but they're really limited. If you want, you can also unalias. This is also a good time to introduce the which command I used a little bit earlier. So, oh, right, this is only in ZSH. So this is a useful thing in ZSH. So you can say like which true. True is a shell built in. Oops. Foo is an alias. This is a function we'll get to in a sec. Lol is a function. So in ZSH, which is a lot more helpful, it tells you what the thing is instead of just is it a file or not. Which is a distinction. It's not as helpful for when you're trying to write scripts, but it's a lot more helpful for when you're trying to do command line things. Yeah, so that's that. Yeah, so we got these aliases, and then we're going to do functions. This stuff is getting more into the weed territory, but I'm going to just show you my 3 favorite functions. One of the things I like doing is, let's say I have this on my desktop, I have this temp.sq, I have this file on my desktop, temp.sq.sq. And in Mac, if you drag it over into the terminal, it'll give you the file, and it'll paste it in there for you. But let's say I want to go and I want to change to that file's directory. I want to go to the directory with that file in it. Well, what you have to do is you have to say cd dir name this. And that's a pain in the ass to do. It's kind of hard, especially like you have to type 20 extra characters or something. And if you do this often enough like I do, it takes a lot of effort. So what you can do is you can actually make a function to do this for you. And I called it cdd, which is stands for change directory to a directory, or dir name or something. So what you do, you say cdd, cd, so what, we'll talk about everything in a sec, but what we'll do is whenever we call cdd now, we can now drag the file over again. Build out, oh, I guess we're already here. That's not helpful. Let me go find another file. Let's go to ~/code/squire. Let's go to include. So now what we're going to do is we're going to do cdd include, and now we're in Squire. So that's how our cdd command works. You can't do that. What you can do, though, is you can do, because GCC allows you to take arguments at the end of the line, you could do alias gc4 equals gcc minus wall minus w conversion, etc., etc. And now when you do gc4, it'll, I'm dumb. Now you do gc4, you can do gc4, I don't know, source/main.c. Yeah, I didn't include things, but you can do that. You can have it do the things beforehand, and that's why GCC is nice, and that's why most shell programs allow you to specify flags before other arguments is because of this alias stuff. Is why generally flags come before arguments. Yeah, so that's a little helpful thing there. You can do this alias GC4 thing. I should add that here. Let's add that to the notes. We're gonna go over here. We're gonna say alias is gonna be like boop. Cool. All right, so back to the CDD. So this is by far my favorite command I've ever written. I use it all the time. So what this does is it says we're gonna have a new. Let's open it in a terminal window. So we're gonna say, whoops, that is not what I meant to do. Hold on. All right, so we're gonna make a new file. We're gonna call this CDD, and so we're gonna say if you don't know what this is effectively telling shell when we run CDD, what interpreter do we use? Do we want this to be a Python script? Do we want it to be a Ruby script, a JavaScript script? No, we want this to be a Bash script. So we're telling it where to go find the interpreter. And we want it to be in /bin/bash. You can also do sh or zsh or stuff like that. So what we're going to do is we're going to make this new function. We're going to call it CDD. We're going to say CDD is going to be this function. And then what we're going to do is we're going to say change directory, or we're going to say change directory to dir name of the first argument. So $1 is the first argument, $2 is the second argument, etc., etc. $* and $@ are all the arguments in an array. They're different, but I'm not going to go over that right now. One thing to note, though, is that because bash is stupid, you have to put double quotes every single time you use a $. So you have to do this, and you have to do this. This is one thing ZSH fixed, is you don't have to use quotes everywhere, but in bash you have to use them everywhere, because if you have a space inside your argument, bash will interpret it as two different arguments. So like if we do, if we go over here and say foo, and we're going to say echo, then do that later. But yeah, that's bash being stupid, so you have to put these around or else it'll interpret them as multiple arguments. So what we do here is we say we're going to take the dir name. So dir name is a special function that's built in, and dir name of this. So what we're doing is it gives us the directory name of doc. But it doesn't have to be a file, it can be anything. It'll just do it for us because it knows how folders work. Yep, I'm still alive. So there's also a base name, which is the opposite, as you'd expect. Base name gives us the base of the name. You can also do, side note, asterisk.text, or asterisk.text will delete the .text suffix. Anyways, but the important part is dir name gives us the directory a file is found in. So dir name of is going to be this. So to make our CDD command, we have the dir name, and we give it the path that we're given as the first argument. So we say dir name and then the first argument, and then we change to that directory. And so this is how we'd write our CDD command. This actually won't work. To make this work, we need to be doing something like this. But even that wouldn't work. We have to add this to a bash RC, which we'll get to in a hot sec. Another helpful command I've written is sublime or subble. So this is a really simple command. What it does is you just say subble and then a path, and it'll open that path in Sublime. So subble, open. So that'll just open our thing in Sublime Text. There's one caveat. If that file doesn't exist, this will just, if $1 doesn't exist, it'll just be open -a Sublime 4, which is not what we want. So the one caveat is I did this. If you know what this means, then great. If you don't, then that's not all that important to you. But that's what I did as a replacement. I can upload these later. Effectively, this says if we aren't given an argument, default it to period. But if we are given an argument, use it. Yeah, you can also do that here, like echo foo. Foo doesn't exist. Oh, foo does exist because we said earlier. That doesn't exist, but we can default it to something if it doesn't exist. There. So if foo1 doesn't exist, we use 1, 2, 3, 4. But if foo1 does exist, we use that. So that's how I wrote subble. Yeah. So custom PS. Let's see. Next up is bash RC. Okay. Yep. Nice. So our bash RC, there's two different things. There's bash RC, and there's a bash profile. And likewise in ZSH, there's a .zshrc and a zsh profile, and there's one for CSH and stuff like that. Okay, so this talk is about becoming more efficient with Bash. I start off with some helpful common commands, and then we talked about the expansion and some really useful things when writing Bash, like history expansion, stuff like that. Then we talked about piping, which is a great way to do pretty much everything in Bash, and that's the main reason people use it. And now we're kind of getting off into the weeds. We're talking about things like Bash RC, which someone earlier wanted to talk about, which is how you can make sure that your code is, your aliases that you write are saved from program to terminal to terminal. Like if you say alias x equals y, and then you go over here and you say y, well, that's not going to be there, and if you make a new terminal, it's not going to be there. So how you save the aliases between things and stuff like that. So that's what we're talking about now. And then when we're done with that, I think I'll take questions. So yeah. So we have these different profiles, and so the difference here is that ZSH profile is always run, and Bash RC is only run when you have an interactive shell. So, Bash RC is run always, and then a Bash profile is only run when you have an interactive shell open. The difference right there is not all that important. It's like, oh, when I run a Bash function, a Bash script like this, anything defined in Bash RC is going to be visible. But things defined in Bash profile are only visible when you open up a new command line. I still stick everything in ZSHRC because I like having them visible everywhere. So let's go take a look at mine. Nope. Alright, so this is my ZSHR. Oh, this is depressing, right? I'm not on my work computer, so I don't have anything here. So what happens is every time I open up a new ZSH, let's make this Bash because we're going to make a new Bash one. So we're going to say open.bash rc minus a sublime 4. Whoops. So we're going to, every time I open up a new Bash window, this thing will be run. So let's say we say echo hi. We open a new window and do Bash. See, it's run as hi. So every time we do something, this file is run. So what we can do is in here we can do something like alias e equals echo, and then we open up, close Bash. Now we say E4, this stuff is saved because whenever you open it, this thing is run. So what you can do here is, this is where you define all your important things. You can define functions, you can define aliases, you can define path modifications. We talked about path a bit earlier, or path is how you can make sure that your things are, you can change where you execute files from. So one of the things you do is export path equals path colon home/bin. So this means anything in your bin directory will also be available within the path. One thing to note is that the functions and the aliases are totally fine. You can just write them normally. But when you have variables that you want to be able to access from outside, you have to export them. So like, let's say we want to take that dictionary that we've been using the entire time. So we want to say dict equals this. So now we go bash. Oh, yeah, that's not actually a function. Let's comment that out. Close Bash. Now I say echo dict. So dict now is going to contain those dicts. So now you can say cat that dict, cat dict, and it has everything in there. You can also, like earlier with GC4, you could do GC4 equal or alias GC4 equals GCC minus W all minus W conversions, stuff like that. And then now whenever you use GC4, as long as you put it in Bash RC, it'll run it. And so that way, whenever you open up a new shell, it'll always be present for you. One thing to note is that this is only when you open a new shell, so your current shell won't be updated when you update this. If you want that to happen, you have to use the period function. So period, and now we will have dict available. So period, just by itself, period space will run a function as a Bash script, and it'll import it into your current environment. You can also use the function source. Source and period are identical for this, but I like period because it's shorter. So that is how you use Bash RC, and Bash RC is extremely helpful. I have it, like in my work computer, I have effectively this. So I effectively have this, and so I just have all these things in here, and I'll also do stuff like this. Oop. Just in case I misspell get or something, because I misspell a lot. Because I misspell things often, alright. So I use aliases all the time because I really like doing this because I use get a lot. I spell things wrong, so I use aliases for that, and I also like shortening long commands. One thing I also use is, at work I have a few production servers I use a lot. So let's say like, I'll do something like that. So I'll put an IP there, and so every time I start up, I can have that IP immediately accessible to me. So I can say like SSH IP1, and it'll immediately go to that for me, and I don't have to go find the IP again. That's another thing I use bash rc for. Yeah, let's see. Is there anything else I was going to cover? No, we already talked about sed and awk. Yeah, I think that is it. Does anyone have questions now? I have no idea how to kick someone, so I don't know how to fix that. But ignore them. So yeah, anyone have questions for me? If not, I'll be beefing this up and upload it a little later. Yeah, I have no idea how to ban. This is my first time ever streaming. I think the TCPP, I think Eisenchan has to ban them. You might be able to report them though. Let me click. Click. Report. Anyways, questions? Yeah, my first time. I had a bunch of issues earlier getting it working. Yes, you can stimulate standard in. One of the things you can do is that's the whole point of piping. So when you run a command normally, it's as if you're piping from standard in. So when you say like read foo. So what that's simulating standard in. So you can say echo hello, pipe it to read foo, and now you echo foo, and oh, I can't pipe to read because I'm dumb. Yeah, you can simulate standard in. You just pipe it in, and then it'll simulate it. You can also use redirections. So, cat hi, this, the caret will read in. You can overload what in means, and the right caret overloads what means to write outwards. So like, let's open up Ruby. Ruby minus e. Put string, get string. Hello. Well, now what you can do is say echo foo bar, pipe it into Ruby, and now we'll say we get foo bar. You can also do Ruby minus e puts gets, pipe it in from this, and we'll use this. So that you can use the triple less than, less than, less than, and then you write a line, and that line will be standard in. Make sense? And then you also can do stuff like, I'm not going to get into here docs, but you can use here docs. Oh, sure. Yeah, all right. Fine. So there's the different commands. Yes, there are more. There are more. So pipe is used to, like, pipe is A, pipe into B. So that takes A's output, puts it into B. A less than B. What this does is it takes the B file, opens it up, and then gives it to A as a input. So you can say cat. So what cat does is it just concatenates standard in. So this less than says take makefile, open it up, and assume that's the standard in for cat, instead of say reading it from the prompt or something. So that's what the input does. The right, that's less than. The greater than is the opposite. It says so take the output of cat, and actually instead of sticking it to terminal, stick it into whatever file name we give it. So we can say cat makefile, and then we're going to stick it into. No, I don't want to be in Squire. Let's do cd temp cat lorem3.txt, and we're going to stick it into foo bar. Foo bar now will contain lorem's code. Then there's a triple equals. This thing right here is the same as this. So you say cat foo bar will give us foo bar. This is the exact same, except for instead of giving it a file name, you give it the direct contents you want. So it'll directly say the oh yeah, hold on. You have to quote it. So you do that, and it'll directly give you the contents you want instead of having to go file name. So this is really helpful for like when you have a short little thing, you don't want to make a whole new file for stuff like that. There's also here docs, which are just the 2 less than. So cat So what it does is you do less than, and then some phrase. And then you can type as many lines as you want, and then when it sees that phrase itself on a line, it'll stop reading and then assumes that's the file. So this is really helpful for pasting in large pieces of text. Like if you want to write a piece of text out to a file, you can do this. Cat end of string some file. Now some file will have that in because we use this less than to take the input of the here doc and stick it into cat, and then we use the greater than to stick it into some file. The here docs there's a few special here docs, like there's this, stuff like that. Those aren't all that important. The main part is just the normal here doc. This one right here will be as if you use single quotes, so that way if you have $ in the code you paste, it won't be interpreted literally. It doesn't have to be EOS. You can do this as like foobar or whatever you want in case EOS is in your string. I just like EOS personally. There's also there's some more stuff. So if you say Ruby -e, whoa. So what warn does is warn puts its output to standard error. So like let's say I take the output and I put to foo.txt. Well, nothing happens because it's not writing to standard out, it's writing to standard error. So what you do is you can do 2 here. You can say 2 goes there. So what 2 means is it says take the file descriptor 2, and this is a little into the weeds, but take 2 and stick it into foo.txt. So 2 is standard error, 1 is standard out, and 0 is standard in. So you can say I want to take 1 and stick it to foo.txt, I want to take 2 and stick it to bar.txt, and say cat foo.txt, cat bar.txt. So standard error is 2, so it went to bar.txt, but standard out is 1, so it went to foo.txt. There's also stuff like, I can never remember the syntax, it's like this, which is closes file descriptor 1. I can't remember exactly what it is, but yeah. Oh, you're right. How did I forget about that? So dev null is extremely helpful. So when you're writing code out and you don't want it to go anywhere, you pipe it to dev null. So like, if I do yes back to yes, it just spans y forever. I don't want those y's, and I don't want them to go on my computer because they're just going to make a massive file. So you can pipe them to dev null, and dev null is a file that just writing to it does literally nothing. It just is empty. Yep, it is. So that way, like if you don't want to read the error of something, like if you don't care about the standard out or something, you can do some command, or let's say Ruby -e warn puts heyo. Then we say take standard error, and we're going to pipe to dev null. What do you mean? Yes, it's 4 lines of code. Yes should be less. Literally should be it. While 1 printf something like that. There is no no. Nope, there's no no. That'd be funny though. But you can do this. Yes, no. You can use man. Oops. Man, yes. So man is short for manual. And you can just say man and something, it'll give you the info about that. So like you could say man grep has this massive, massive file. What, printf? Yeah, no, it's just yes. Just yes, nothing else. If you want, though, you can actually find all the commands. If you ls/bin, oop. /bin has all the normal commands. So every computer you ever log onto will have these. Yes literally just writes Y forever. Or if you give it an argument, it just writes that argument forever. Like if I was writing this in C, it'd be because that's the thing. That's the entire function. The whole point of Bash is to have the whole point of Bash is to build up these small little functions and put them together, kind of like sort and unique or stuff like that, where they don't do much on their own, but you stick them together and they can do more things. So yes, you can use to like, oh, you transform the output to be something, and then you can pipe that into some other file. Or I don't know. I don't really use it a lot personally, but I find it kind of funny. If you want to find all the commands you can do, you can ls/bin or /user/bin, and that'll give you all the commands you have on your computer, like sed or secure copy or everything in here you can run. So yeah, anything else? Parl? What's Parl? Never heard of Parl. For which? Yep. Where did it go? Where's Parl? Anyways, those, yeah, ls/user/bin. Actually, if you look at echo path, if you look at the colons, everything out between the colons is where the bash will go to find things. So if you do ls/bin, ls/user/sbin, ls/sbin, there's all these different places you can go to find the commands. So yeah, so oh yeah, PS1 is really cool. You can use this thing right here, which should, let me pull it up so you can see. Let me go grab it. So you can change what your prompt looks like using these things. So my prompt right now is just \w, where it's \w and a $sign. So you can use these things to just do a bunch of cool stuff for you. You can make it print out the current history number, for example. So like that's what my ZSH shell prompt is. Like whoops. Oh, I forgot this is ZSH special, but so the PS1 is \s, which is shell, --v, which is the version, and then the $sign. So you could do PS1 equals the current, the working directory, the date, the history number, and the command number, and then a $sign in space. And so we're currently working in tilde. The date is Saturday, August 8th. Our history number is 207, but our command number for this instance is 4 and $sign. So you can just customize this a lot. You can also make it do colors. I'll give this link here in this chat. So yeah, you can use that to customize it. If you do customize it, you should put it into bashrc, because yeah. Anyways, cool. Yeah, thank you guys for listening. I think that's it. Yeah, if you have more questions, you can hit me up. I'm happy to talk if you need help. So yeah, thanks. Ooh.